Hello everyone, the topic that we are going to discuss today is bidirectional shift register. So, we will see what is a bidirectional shift register, then we will go into the details of bidirectional shift register and we will see its applications. So, first of all, what is a bidirectional shift register? So, bi, always bi stands for 2. Bi stands for 2. Bidirectional means 2 directions. Okay, fine. So, it is a circuit used for shifting data either to the left or right. It is a shift register. So, that is the reason we are discussing about shifting data. Bi stands for 2. So, you shift in any of the 2 directions, and the 2 directions that we know very well are left and right. And how do you control whether there should be left shift or right shift? We use a control input. Okay, we use a control input. So, here this is the control input here that we are giving to the input of this NOT gate. Based on the control input, the shifting takes place either left or it takes place either to the right. So, now to understand this better, to this circuit, let us say we give an input of 0. Okay, to this circuit, when we give input 0, let us see what is the situation. So, output of NOT gate we get a 1. Okay, at the output of, when you give a 0 here, at the output of NOT gate we get a 1. So, now how NAND gate works is, when one of its input is 1, okay, the output is same as the other input, means here this NOT gate we are going to get a 1. Okay, likewise here also we are going to get a 1, likewise here also we are going to get a 1, and then here also we are going to get a 1. Now, this is like a switch and the switch is on. What do you mean by switch is on? Now, this signal, second signal will pass to the input of OR gate. Likewise, because we have a 1 here, the output of the AND gate will be same as the second input. So, this is the second input, and whatever you get, whatever you give here, the same thing we are going to get here. Likewise, now this is equivalent to being connected here like this, and then this is equivalent to this point being connected here. Likewise, this is equivalent to this point being connected here. Now, what we are going to see is the functionality of this OR gate. To understand that, let us see what is the situation of the another AND gate that we have here. So, 0 is being given to this AND gate. Here we are going to give a 0, and you know AND gate, if any input is 0, then output is always 0. So, we are going to get a 0 here. Likewise, we are going to get a 0 here at this place. We are going to get a 0 here at this place. Again, we are going to get a 0 here. Now, the output of the OR gate is very simple. 0 or anything is anything. Fine. So, now it is as good as this signal is being passed here. Now, the same thing. So, when we give a 0 here, the connections are like this. It is as good as this AND gate is connected here, and then this AND gate is connected here. Likewise, this AND gate is connected here. Okay. So, now in this situation, let us see how the signal moves through the circuit. So, now because of this particular connection, let us analyze here the signal that we have here. The same signal is going as, if you see the signal that we have here, the same signal is going as, okay, it goes in this path, then like this, and then input to this gate. So, the output of the flip-flop is acting as the input to its previous stage. Now, because this is a symmetrical structure, the same thing is valid. The output here acts as input here. Similarly, the output here acts as the input to the previous stage. But in this case, what happens? Let us see. In this case, there is no previous case. If you see, this is the flip-flop, right? So, what happens? The output is out of the, it goes out of this particular flip-flop because there is no previous stage. Fine. So, the output here is connected here and this output is connected here. This output, there is no previous flip-flop, and that is the reason it is simply outputted from this shift register. It goes out of the shift register. So, now here what we have understood is when we have given 0, the data is shifting in leftward direction. Reason being, the output of a flip-flop is connected to the input of another flip-flop which is towards left of it. So, here when we give 0, it is acting as left shift. Now, similar analysis we can do and we can conclude that when we give a 1 here, when we give in place of 0, when we give a 1 here, so this becomes 0, output of NOT gate is always complement of its input. So, when we give a 1 here, it will act as right shift. Similar analysis can be performed as we have done here, and then it acts as the right shift. Now, whenever the signal is shifting, you expect input. Now for left shift, the data is being shifted in the left direction. In such a case, we provide a extra input at the left side. Here it is represented. Likewise, for right shift also we provide input, and that particular input is represented here in this place. I hope the concept is very clear. To understand this, I recommend please look at the previous video on the basic introduction of shift registers. Now we are going to discuss its applications. It is used in storing data. You can send the data serially into the shift register and that can be stored. And the data can be stored and retrieved in an efficient manner because you can do it in either direction. It performs arithmetical operations such as multiplication and division. For example, let us take 1 0 0 0. Let us shift it. Say I will do right shift. Bidirectional shift register, we can shift in any direction. So when we do right shift, we are going to get 0 1 0 0. How are we getting that? All digits we are shifting towards right. So actually we are supposed to get this. The last bit is out of the last bit goes out of the sequence because we are shifting towards right. So one value is leaving the flip-flops. But in such a case, we take an extra 0 at the left. We take an extra 0 at the left. And that is the reason right shift gives us this sequence 1 0 0, right shift gives us 0 1 0 0. So this, if you see, the decimal equivalent is 8 and this, if you see, the decimal equivalent is 4. So what operation is taking place here? Division operation is taking place. When we do right shift, division operation, in fact divided by 2. Likewise, you can analyze, if you do left shift, it will give you multiplied by 2. So, arithmetic operations can be performed using bidirectional shift registers. Next, in microprocessor and microcontroller, it is useful for bit manipulation. For example, you want to maintain secrecy of the data. What you can do, all the bits you will shift and you know that you have shifted by how many digits, but any other person may not know, right? And that can be used for data encryption. Likewise, suppose you have value something like this. Then what you can do, you have so many zeros here. You can shift and you can only pass the non-zeros, and as a result, the amount of data that you are transmitting or storing reduces. Ultimately, we are able to attain compression. And any other manipulations based on the practical applications can be done by using the bidirectional shift register. Then, in LCD display drivers, here you can shift data to appropriate positions for display. Let us understand this with an example. Suppose, let us take one LCD display. Let us take one LCD display, say like this. I hope all of the students here are familiar. This is a 7-segment display. Now here, if you want to represent, say, a value 2, then this is how it is represented. A value 2 can be displayed like this. So, how we can achieve this? Turn on this segment, this one, this one, this one, this one. Here, these two segments, we will keep them in off position, only the tick marks in on position. In such a case, the display 2 can take place. Now, data can be sent serially to this display one by one, and it can be shifted, and then this particular display can be shown on the LCD display. So, this is how we can have application in LCD display drivers. And where all we have LCD displays, for example, digital clocks, calculators, any other, okay, alphanumeric displays. Then, next application, data communication and networking. It is used in frame synchronization, where bits need to be shifted in both directions to maintain proper alignment. If you want to align data, for example, let us say there is data like this. Another data is that you have received, okay, is something like this. It appears that, okay, both these data are different, but when you actually shift them, for example, if we shift this towards left, what you can identify is actually the same pattern is being repeated here also, okay, the same pattern. One more shift, what you can identify, the same pattern is being shifted here. So, for such applications, we can make use of the bidirectional shift register. It could be shifting in left or right for proper alignment. Another interesting application could be in your television screens, okay, in your, for example, if you have frame has so many bits of data, right, so many bits of data frame has, and through proper synchronization, proper image can be achieved. Okay, next, in signal processing, certain filtering algorithms. If you see, when you convert from one domain to another domain, say for example from time domain to frequency domain, then what happens is some signals, okay, some mathematical operations are converted into shifting. There you can make use of the shift registers. So, we have seen so many applications of the bidirectional shift register, and as a summary, what are all we have seen? We have seen bidirectional shift register, and we have seen bidirectional shift register is nothing but a register where either you shift left or you shift right, and we have also seen the applications of bidirectional shift register. Thank you so much.